My name is Jacob Feldman, and I am Chief Technology Officer of OpenRules Inc., creator of highly popular decision intelligence framework known as OpenRules. Today, I will do introduction to our product, and I will do live demonstration with one objective: to let you quickly start, create your own decision services using OpenRules. You can get information, a lot of information from our website, openrules.com. We also have a synonym website, decisionmicroservices.com, because the main objective of decision intelligence framework is the creation of decision microservices specific for our customers. OpenRules is a business rules and decision management framework used by modern enterprise to support the decision-making applications. The main product, what we provide, OpenRules Decision Manager, is a decision modeling IDE, interactive development environment, that includes a super fast rule engine. We also have several more products built on top of our products. In particular, I'm not going to talk about them today, but you can learn from our website about Rule Learner for rules discovery using machine learning, a Rule Solver for decision optimization, allowing you to find not just one solution, but multiple solutions and find the optimal solution among them, RuleDB for integration of your decision services with relational databases, Rule Dialog for rules-based web questionnaires that could be created by business people without being experts in any HTML or other web technologies. OpenRules provides technical support, and we well known for this. We provide training, consulting services. OpenRules is very active in research and development in the decision modeling domain. Along with a good product with proven records, we also provide methodology. It's very important, even with the best product, to know how to apply this product. We call our methodology goal-oriented decision modeling, and you can read about this on our website, or you can just purchase a few books at Amazon about this methodology. A few words about our company. OpenRules is a small New Jersey business. We were founded in 2003, and since then, we have thousands of real-world production environment when our large and mid-sized customers using every day OpenRules for millions and millions rules-based transactions. OpenRules became profitable in 2006, and we stay profitable since then. And this is our main source of our income. OpenRules is well known for its, I already mentioned, supreme technical support, good documentation, for our orientation to business analysts who can work in concert with IT people. And as a result, over these years, we got a lot of industry rewards. And that's what analyst companies such as Forrester said about OpenRules. OpenRules have the most aggressive approaches to business expert authoring, and typically requires less developer support than our major competitors like major commercial products, IBM ODM or FICA or Red Hat rules. And here a few differentiators, and among them probably ease of building, testing, and deploying complex production level decision model is the most important one. OpenRules among the fastest rule engines available on the market today and can handle large payloads. Why people select rule technology in general, such as OpenRules? And if you're new in this technology, let me briefly describe the reason for migration to real rule engines. The main reason is desire of modern corporations to quickly change their business logic. And to do this, they cannot live in the old world when in any software landscape, business logic was distributed in multiple locations. It could be located in SQL queries. It could reside in stored procedures in database. It could reside in Java or Python code or some legacy code. It can reside in graphical interfaces. And every time when you want to make changes in one place, you have to think how it affects changes in another place. And so changes become a big problem, and making changes is a major driver from this architecture on the left to the architecture on the right. When all business logic components are externalized in so-called rules repository or knowledge repository and represented in form of decision services, and the same applications continue to call these services when they need to make a decision. In this case, when you're selecting products like OpenRules, you need to answer two questions: how to manage this externalized logic, what business people will do, what developers will do, how efficient are these services, can we run them really quickly, can we handle millions of transactions per day with less than 1 millisecond performance? And OpenRules answers yes to all these questions, and I'm going to demonstrate this below. Okay, so typically, when you use OpenRules decision services, you have this simple picture. If this is your existing system with your graphical interface, with your process management components, with your persistency services, you just want in certain moment of executing your decision-making application, you want to call externalize decision service, send to this service request information, frequently in JSON format. This service will execute your business logic, usually represented in form of business rules, and it will produce a request again in JSON format, and it quickly comes back to your application, and you can show results on graphical interface or save it in database or continue calling other services. And these decision services could be deployed in any environment. In modern systems, you want to be able to deploy them on premises using, for example, Java API, or deploy them on any cloud environment like Amazon, for example, AWS Lambda, one of the most typical destination for OpenRules decision services. Also, our customers frequently use Azure Functions or any other RESTful web services, and we even can generate automatically Docker images, and which you can put in your favorite environments such as Kinesis and any other cloud environment. And so the main question becomes is how to create and maintain these decision services. And to do this, we're following approach already commonly accepted in international standard known as DMN, Decision Model Annotation. In this standard, people usually define business decision model. And the word business is really important this because these models are created and tested by subject matter experts, usually by business analysts. And when you're creating your decision model, different products provide different representation of rules repository, but format of your business rules, such as decision tables, usually is well standardized and understood by majority people who follow DMN standard. So in OpenRules situation, we offer users a representation of business rules in using just basic Excel. In using Excel, Excel is the best table editor. And everybody can compete with Excel, but Excel or Google Sheets still the best table editor. And the only thing what we need is table editor. We don't need Excel formulas. You don't need Excel during execution. It's just editor of tables. But all these tables could be redistributed between different Excel files. These files could be placed in different folders, subfolders, based on their objectives. For example, you can have different categories for different lines of business, or for different customers, or for different regions, and you can have common rules. And these common rules would be shared by different categories. Some of common rules could be overwritten by these rules, and basically, creation and maintenance of rules repository is the most important part of business decision modeling. And I specifically want to stress that along with rules, you also create test cases. And each test case provides input information, test data, and also expected output. So when you prepared your decision model, you can just with one click to button test, you can run OpenRules engine. It will validate syntax of your decision model. If you made mistake, for example, mistyped the name of some decision variable, it will tell you about this and point you exactly where this error occurred, in what file, in what table, and in which cell of this table. And after you fixing this error, OpenRules will produce results by executing all related rules. And after execution of these rules, you will get results, and these results would be automatically compared with expected results. And if you see errors, OpenRules mismatches, OpenRules will point you to these mismatches, will tell you exactly where they occurred, and will ask you to fix this, to make fixes. And while doing this iterative decision modeling, at the end, you need to come up with good results. If you have difficulties, you will use OpenRules debugger, friendly business-oriented debuggers that will help you to find why this rule was executed and this rule was not executed. And a lot of these things I will demo to you today. And finally, let's assume that business people already built and tested the decision model. Then with one click of button, based on some deployment parameters, they can click button deploy, and they will create new, or they will update existing decision service. And your application will continue to work with this new version of service based on your CI/CD technology supported on your application side. What is one is important thing to remember? Every time when you want to make changes in your decision service, you never go directly to service. You go to business rules repository, you make change it here, you test all these changes, and then you can redeploy your decision model. And of course, you always can switch between different deployment options, because deployments basically becomes a commodity after first successful deployment, and then all changes done only in business decision model. Hopefully this is enough for introduction, and we can look on very simple particular system. And this is, I will do a demo for you, and I will use this business problem to demonstrate different functionality. And imagine that a patient visited doctor, and doctor decided set diagnosis for this patient, and now based on this diagnosis, doctor has to decide what medication to give this patient and what doses, and doing this, it should consider different special cases. And for example, medication rules would be very simple. If patient is 18 years old or older, then this is recommended therapy choice. If it's less than 18, then this is recommended medical therapy choice. But there is an exception. If patient allergic to penicillin, then therapy choice should be this one. And when they calculate different dosing, they should consider quite interesting calculation formulas, and they also should take into consideration relationship between different rules. For example, drug interaction rules can recommend that you cannot give this, can warn you about giving patient such and such medication. Hopefully you got the general picture, and let's look on implementation. This is example of the first decision table, how it's implemented for medication rules, the same what I just told you about. And they represented in the Excel table. And you can see in the left top corner, we always use keyword. And this, in this case, keyword is decision. Name of this table is defined medication. And this table consists of two conditions and one conclusion. First condition could be, let's look on first condition and the first rule, this rule. And we can read it exactly like here in plain English. If patient age more or equal 18, then recommended medication is amoxicillin. But let's assume that this patient is 25 years old. If it's 25-year-old, first rule would be executed. And when we go to the second rule, it will check, is patient age less than 18? No, it's 25, it's more than 18. So the second rule would be skipped. And then we go to the third rule. And then third rule will check, is this patient allergic to penicillin? And if this patient is allergic to penicillin, then this rule would be executed and previously recommended amoxicillin would be replaced with levofloxacin. Hopefully, it's quite simple logic. The only thing I want to tell you is that this is example of so-called multi-hit decision table. It means this table executes all rules in top-down order. And as a result, it allows this rule overrides, that this rule, rule number 3, overrides rule number 1, right? But there are also, and this is multi-hit table defined by the keyword decision. But if we go to dosing rules, here you will see that in the left top corner, we have another keyword decision table. This is the most frequently used decision table called single hit decision table. And difference between decision table and decision is that single hit decision table stop working when it hits the first rule. For example, if it hits, let's consider this table, how it works. Our patient, I told he was 25 years old. So when we go to this table, we look on the first rule. Is the patient age within 15 to 60? Yes, I said that he's 25 years old. So this would be recommended medication and all other rules would be ignored. But let's say this patient is 65 years old. Then first rule would be skipped, and it means this decision table will look for next first satisfied rule. And then, so it will analyze the second rule. It will check patient creatinine clearance. It will calculate patient creatinine, it will check creatinine level, and then it will check creatinine clearance that, if you remember, should be calculated based on some formula. And if both conditions satisfied, then it will recommend this dosing and end of work. The table will continue. In this case, the third rule just tells that more dosing rule is needed because it does not cover all possible combinations, this table. So it's not complete table. Okay, but hopefully you got the idea and difference between multi-hit and single-hit decision tables. And these two simple tables with a combination of different conditions and action can resolve a lot of problems and represent the most complex business logic. One more thing very important to stress. You can see here when you see multiple conditions, they always related with logical and. If this and this, never or. If you want to go to or, you need to create another rule. This rule or this rule or this rule. The same thing, this rule or this or this. Never conditions connected only with operator and. The same thing, you can have multiple conclusions. Instead of the word conclusion, you can write then or action. Instead of the word condition, you can use if. So it's quite friendly, and hopefully you got a general idea here. Now let's look on the formula. Remember, we had this complex formula, and this formula is more difficult to read on the right than to read this here. It's a decision table. Name of the table, calculate creatinine clearance, and it has a single action, or we can call this conclusion, unconditionally calculate patient creatinine clearance using this formula. And you can see this is not Excel formula. This is a formula presented in the format that is simple for business users. You can see even we can use here spaces in the names of variables. So it's quite intuitive. And finally, about this warning about drug interaction. If recommended medication defined in this table, right here, is levofloxacin and patient active medication is commodine, then we need to produce warning, a drug interaction warning about reduced effectiveness of commodine. So that's clear. And now look on the most important component of decision modeling called glossary. This is another table, and this table starts with keyword glossary. And in the first column, we list all possible decision variables used in all our tables. So for example, patient age, patient allergies, patient age here, so, and we can split them classify them based on categories to which they belong. For example, patient age obviously belongs to the business concept patient. And patient probably, they can add here name, patient can have weight, allergies, and other information. And but for example, encounter diagnosis and recommended medication, this is something temporary, what related to business concept, what we can call doctor visit. And in this case, this is natural classification. Technical people can think about business concept as a business objects, but it's not necessary for business people to know about object or object orientation. And what is now important to look on the third and fourth columns here. This third column, this is the only place for integration between business and IT. And here technical names of the same variables. For example, if you use JSON interface, these would be names of JSON attributes. If you use Java, it would be names of Java attributes. Usually we follow here camel convention, no spaces allowed. And the fourth column represents types. In this case, you can see string for text, int for integer, double for real numbers. This is allergy, it's array of strings. So this is, it means arrays. And you can use your own objects like patient, doctor can have multiple patients, and et cetera, et cetera. There are a lot of other very important columns here, but that's enough for to represent this decision model. And basically, this is a complete model ready to be tested. And the only important thing I still want to stress is that with OpenRules, contrary to some other products, you don't have to manually define sequence execution between execution sequence for different tables. For example, it is obvious that this patient creatinine clearance should be calculated before we're running defined dosing. So it means table calculate creatinine clearance should be executed before this table. And how you can do it? You can, many products draw so-called decision requirements diagram, and they draw error. This table should be executed before this table, but this can create a lot of problems. If you want, you can use this, but OpenRules allows you to automatically resolve all these inter-table relationships, and it makes, obviously, OpenRules much more friendly and maintainable from long-term perspective. Okay, so as a summary of this introduction, you can see we had different decision tables, and they all define different goals and sub-goals defined inside glossary. So in general, you can think about decision model, business decision model, as a glossary surrounded by decision tables that specify different goals and sub-goals. Okay, now it's time to switch to actual implementation and see how it works. For example, first of all, I want to tell you how it looks from Windows File Explorer perspective. We created here patient therapy. It's a project when you download OpenRules, you will get this decision model. It would be folder patient therapy. We created subfolder rules, and this is our rules, simple rules repository. And we placed all these tables, what we discussed, in different files. For example, glossary was in separate file, all rules here. We also created test cases. I will show them you in a minute. And now what is important. So you can run everything. For example, when you click, you can modify this file. So you can click test, and this test will execute engine, will produce results. You can do it without any graphical interfaces. But it's much better and friendlier for large models to go to our interactive development environment. And you can do from there deploy. You can have buttons deploy here as well, but let's go to interactive environment. In this, I will do live demo for you, and let me switch to graphical interface. And this is our graphical interface. And first, when we can open different models. For example, here, how I can open these models, but this model is already open patient therapy, and you can see right now only so-called goal view of these models. You can see that we have patient therapy, and patient therapy depends on recommended medication. Recommended medication depends on drug interaction warning, and it depends also patient therapy on recommended dose, and recommended dose depends on patient creatinine clearance. So all these errors were built automatically by OpenRules. And of course, you can move it if you want. You can make it larger. All these connections would stay. But now I can go to Legend on the right, and let me open here decision tables that actually represent this logic. So they all show in blue color, and behind each of them, some decision table defined in Excel. For example, if I click here to define medication, so it will show me our table. You remember this table. And if you want, I can even click open Excel, and I will open this in Excel. So you can see it's open, selects the required tab. It shows you where is this medications, and this is the same decision table what you've seen on my slides. You can make changes here, and then when you save changes in Excel, they immediately will be shown, reflected on this picture. And so this is a so-called decision requirement diagram. You can show even more. For example, where is my input information? When I click input, it will, all this white shape will show you information that required to execute this, to execute different logic. For example, you can see that this patient creatinine clearance depends on patient age and depends on patient weight. And but it will produce patient creatinine and from patient creatinine level. So I can move it here, then it will tell me about recommended dose. And from these diagrams, we can also we can hide input, we can show only business concept, and you can see through all these errors who depends on whom. And now I'm ready to actually execute this table. And when I click on this running man, I will switch to so-called test and debug view. On the left side, we have different tests. And let me show you, for example, one test. In this test, first test, you can see it's just, it opens test XLS file. And it's, for example, it has 3 tests, like here. First test shows patient 50 years old, weight 78. This patient has 2 allergies, including penicillin, active medication Coumadin, and this is the current creatinine level. And on this was blue input fields, and red are expected output fields. So we expect that recommended medication will be this, recommended dose will be this. Okay, and now I can just try and run it. If I run test 1, so now OpenRules will detect that changes were done. It's rebuilding system. Internally, it reads all information from Excel, generates Java code hidden from all of us. But specialists always can look at this, but it's not necessary. And it produces results. You can see successful results here. And this is a black screen, nothing fancy, but it shows all executed rules. If you want to analyze these rules, it's much better to click to produce report. It's produced in HTML format. You can open in a regular browser, but it shows in this format. This is quite friendly format. It shows you only executed rules in this report. You can see which table was executed, which rule. It shows, it reformulates this rule in regular if-then statements. And on the right side, it shows current values of each variable, and so you can analyze why this was executed. For example, rule 1 was executed, and then rule 2 was not, and rule 3 was executed, like I explained you previously. And you can see all executed rules, and finally you can get these results. This table, our customers love these reports, but when you have hundreds and hundreds of rules, this becomes too overcrowded. And our customers like to run something what we call debugger. If you click on this button, OpenRules will prepare debug session for this model. As you can see on the left, this is diagram. Now we can see on the right. And the first rules to be executed define medication. They highlighted with orange, and you can see this table define medication. And we are about to execute the first rule because it's green. It means if it's green, it's going to be executed. If it's not green, you will see explanation why it's not going to be executed. So when I click on the button next rule, we can execute rule one by one and analyze the state of our system. For example, so if it's executed, our recommended medication right now, if I click on recommended medication, it's empty, right? Nothing. But if I click on this rule, recommended medication should become, let's look on this. Yes, it's amoxicillin. So it's rule executed, but because it's multi-hit table, it goes to the second rule. But this rule is not green, it's yellow. And in red, it shows the reason why this rule would not be executed, because age of person, let's look where is the patient age, input, and patient age here, 58 in this test. That's why it would not be executed. So when I click, nothing will change, but the third rule is going to be executed. Why? Because patient allergies. Patient allergies include penicillin, right? So now our recommended medication was this, but after executing this rule, recommended medication will become levofloxacin. And now OpenRules already completed this table, and now it's going to execute calculate creatinine clearance. And please note that it's automatically found whom to execute, because before executing recommended dosing, it should calculate creatinine clearance. And this is a formula familiar to you, right? We already considered this formula. When I calculate this, we will see that creatinine clearance would be calculated, whereas creatinine clearance here, it highlights the last calculated goal. This is our just calculated creatinine clearance, and we can continue to use this. Now we got to the warning about drug interaction. So this is rule would be executed because recommended dosing already defined here, and only warning. And this warning, yes, it's because the active medication is Coumadin. Where is active medication here? It's Coumadin, so it would be executed, and warning would be produced, and our results. As a result, we will complete our model. It shows you summary, how many rules were executed, how many times which rules was evaluated. It gives you some useful information. But now I want to show you, for example, how to use breakpoints here. For example, I can, let me start. I do have here different views. I can show the same instead of diagram, all variables in table format. I can show you breakpoints. And breakpoints, by the way, this is where you can stop. Instead of executing rules by one, you want to stop in the certain moment. For example, I should stop in rule number 2 for defined dosing. If I look on this on this picture, let me just do restart. So now my debugger will stop again, will start execution again. It stops on the first rule, and instead of executing one by one, I want to tell go to the next breakpoint. Oh, I did not set breakpoint for the first test. Let me go, so first test does not have this breakpoint, but if I run, for example, second test, I think it should stop in this breakpoint, and I will. And when I go to the breakpoint, okay, you can see it skipped all rules and stopped already in defined dosing. And defined dosing, second rule would be executed. and you can analyze why. So to set up a breakpoint, I can do this, just click, and it's breakpoint, click, remove. And that's how it works. Hopefully you got the picture. And now, finally, I can do very simple thing. So let's assume that our model is completely executed. I can execute all tests, see that they all were executed. For example, all 3 tests were executed successfully. So now it's running all 3 tests successfully. So I can do deployment. Now I click on the button deploy. And when I click on the button deploy, it shows me my deployment parameters. For example, I decided to use here AWS Lambda and use US East region. We're located in New York area. So, and when I click deploy, it will actually start deployment of our already tested model to Amazon web service, and it will deploy the system. Now you can see it's executed tests to make sure that there are no errors. And now it's actually generates Lambda, and it should produce endpoint URL, which we can already test from any applications that knows how to use web services. So it's done. You can see this invocation URL. So if I click here, I would see you produced endpoint URL. I can copy this endpoint URL and I can use it to debug our system from external application. For example, I can go to Postman, okay, or any other application, and it would be ready to execute. Okay, so now it's also, by the way, producing JSON tests automatically. But let's continue. We don't have too much time. And now I want to show you what actually happening. So now you've seen already this graphical interface, and there are a few examples of other rules. You can see that we can present different tables. And what is I wanted to stress is that when all rules not executed, the last rule for single key decision table would be default rule. And if you have multi-key decision table, so you usually start your default in the first rule. For example, in this scorecard, we calculate applicant credit score. We make this applicant score 0, and then based on values of these 4 different parameters, we can increment this credit score. Okay. And let's look on another table. This is a multi-key decision table. I just want to show you that you can use operators like this less, or you can have operators in separate columns, or you can use operators is one of. In this case, by the way, so internal credit rating is one of A or B or C. I told you you cannot use or you go to another rule. But in this case, it's just inside the same cell. You can use or like this using comma. And a lot of other opportunities. We have more than 50 different operators. Is one of, is not one of, includes, contains, intersects, all other operators you can imagine. After 18 years being in this business, we basically cover everything. And finally, I just want to stress what the importance of life cycle of your decision project. When you start your decision project with just plain English description of the scope of the project, then you define goals and immediately glossary and immediately test cases. And when you then you start to implement real logic that produces right test results. And when you go iteratively through this process and you got good results, you click button deploy, and your decision model will become deploy decision service that you can monitor and maintain directly from your deployed environment, such as AWS, and you can follow all regulations defined in your CI/CD environment, including OpenRules supports all security environments, and we provide all necessary features for CI/CD. Okay, and Now we have only few issues to cover today. It's a relationship between business people and developers. What business people do? They usually create and maintain business decision models. It means they define business logic inside decision tables. They specify glossary, and they define and execute test cases to make sure that their logic works fine. But they involve developers to do integration. And integration, if you remember the third column in glossary, this is, developers come, look on this third column, and they tell, you need to put here such and such technical names of your decision variables that usually they correspond to JSON or to Java attributes. Also, sometimes you need help to create your domain-specific tables that they're more convenient. They could be more convenient than the general tables, and OpenRules provides very powerful templatization mechanism, and it's better if your technical people will help you with this. And you also would need help with your developers for the deployment and integration. But the best results we know from real world experience are achieved when business and IT work together.